Okay, we should be well on our way here. All right. Hi, everybody. My name is Ian McLaughlin, and I'm a PhD student at the University of Pennsylvania, PhD candidate for now, at the University of Pennsylvania, and I study anxiety and addiction, and I like to talk about the brain with people outside of science. It's kind of a privilege to get to do that. It helps to remind me of why this is an interesting field, particularly in the doldrums of graduate work. Well, why don't we just go into going live again? There were some interesting studies that came out, I guess, before we start. So one was when you have a baby, one of the things that you hear, like right when the baby is born, there is a word that you hear over and over again. It's a word that you study in introductory biology, perhaps, and you promptly forget about it because you never hear about it again until you have a baby, and that, or until if you go pre-med, or if you become a physician. And that word, this is going to be terrible. That word is bilirubin. You constantly hear about bilirubin in the hospital because that's the thing that everybody's watching for your baby's health. It's bilirubin levels. How are the bilirubin levels doing? And it's because it sort of correlates with their excretion functions. And what bilirubin is just a breakdown byproduct of heme. You might recognize heme from hemoglobin. And oftentimes babies build up levels of bilirubin to levels that need some mitigation. And there are a bunch of interesting ways that is mitigated, the primary way of which being light therapy, where they basically put, I don't know if you can see it. Actually, let's see if you can see it. See, there's sort of like a purplish light coming from above my plants. Well, basically they spray your baby with blue light, and that helps to break down bilirubin. Anyways, there was a finding that it could be the case that levels of bilirubin in the brain may function as an antioxidant in a way that is distinct from typical antioxidants of which you might have heard, like glutathione, for example, or cysteine. And antioxidants are important. Their importance is exaggerated oftentimes by the supplement supplement business, suggesting that everything that ails you is derived from too much reactive oxygen species building up, and there's some truth to that, but we have our own endogenous antioxidant activities that quench those reactive oxygen species. And in reality, reactive oxygen species actually do play important roles in signaling between cells and in the immune system, for example. Anyways, there was a group that basically found that it turned out that in mice that were less capable of generating bilirubin, they had knocked out a specific gene, excuse me, that is sort of responsible for generating bilirubin levels or sustaining bilirubin levels in the brain. When neurons became hyperactive in these mice, and again, these mice were incapable of sustaining high levels of bilirubin, it turned out that damage to neurons derived from that elevation of brain activity was significantly greater, 2 to 3 times greater than mice who were capable of sustaining normal elevations of bilirubin. And so it's sort of like this most mundane molecule to focus on, because it's who cares about bilirubin? It's just one of those standard things that physicians test for to evaluate kidney health and stuff like that. But it may be playing a fairly significant role in the brain, particularly in conditions of duress, perhaps during seizure or during injury, or perhaps during stroke. And so in any case, it was sort of a surprising finding, because it is, again, this sort of mundane molecule that nobody really cares very much about. And this was a study, by the way, that was done at Johns Hopkins University. There was another study that came out that basically showed, I think most people now who are at least peripherally familiar with the effects of drug use on fetal development and just brain health in general, it's sort of appreciated among that group that fetal alcohol syndrome is a bad thing. Drinking while pregnant is not advisable. But this group found, it was at Rutgers University, right across the river, basically, in New Jersey. I'm in Philadelphia, that moderate to heavy drinking during pregnancy was associated with genetic changes in both the mother and the resulting child in two specific genes, one of which is pretty well known. It's a very important gene called POMC, POMC, which is an initialism, or actually an abbreviation, for pro-opiomelanocortin. And so you might recognize a bunch of those sort of syllables in that name. And basically what it is a large protein that's then cleaved into a bunch of other signaling molecules like melanocyte stimulating hormone, or adrenocorticotropic hormone, ATCH, or beta endorphin. You've probably heard of beta, or just the endorphins. Beta endorphin is usually what people are talking about when they say endorphins, as well as other sort of related signaling molecules called the enkephalins. In any case, there were modifications of that gene in both mothers and their children following moderate or heavy drinking. And then another gene called PER2, or PER2, which is pretty well established to be a signaling, or to generate a signaling molecule that regulates circadian rhythm in a part of the brain that's been well established to regulate the circadian rhythm, the suprachiasmatic nucleus. And so, this isn't surprising, right? I mean, I don't think anybody would be surprised that there would be any kind of changes in genetic expression following fetal exposure to alcohol. But this is sort of part of the work of enumerating what those targets might be, and then potentially down the road resulting in therapies to try and mitigate the damage derived from fetal alcohol syndrome and sort of correct as early as possible, correct for that damage to return development or the developmental trajectory of the children to something that would be more like normal, or as though they were never exposed to alcohol while in the womb. And so, just so you know, moderate and heavy alcohol consumption for females, at least in the United States, is slightly lower, or what qualifies as those things is slightly lower than men. And so heavy drinking in females is 4 or more drinks on at least 5 occasions in a month, and then moderate was 3 drinks per occasion, at least 5 times a month. And so again, this is still kind of early stages to try and mitigate damage from fetal alcohol syndrome. Of course, the best thing to do is to not drink while pregnant. But it's compelling work, and it also helps to understand. Okay, so what are these signaling? What are these genes and the signaling molecules that they generate? What roles do they play in the brain at baseline? We can learn a lot about how the brain works by looking at it in a perturbed situation, right? Change the system in a very specific way, and then we can see what the resulting differences are, and that gives us some insight as to what those perturbed systems do at baseline. And so there are a bunch of other studies, like there was this cute study from the University of Colorado at Boulder that basically showed that when a woman is in a state of pain, it turned out that if an empathic or empathetic partner held her hand, not only did that mitigate levels of pain, which has been sort of well established, it's part of the reason for why when a mother is giving birth, if the father is present, the physicians will sort of compel him to hold her hand and sort of just be right next to her. I know I was there. It was very intense. But this group at UC Boulder basically found that not only did it help to mitigate pain levels, but it also actually resulted in synchronization of certain physiological markers, like, for example, respiratory rate and cardiovascular rhythm, which is kind of cool. And, my wife was like, oh, shocking, you're watching me breathing, and, maybe that sort of synchronizes everything up. And maybe that's true. However, the study also found that if the partner was in the same room, and just not sitting next to the wife, let's say, but not holding her hand, that physiological synchrony was not established. And so, kind of interesting. There's some, potentially some subconscious amplification of empathetic sort of social bonding and social interaction going on there, but potentially. And I keep saying husband and wife because this study was done in 22 heterosexual couples. And so, it's just not established as to whether or not this is, sex dependent or that kind of thing. But it is interesting that the cardiovascular rhythm was synchronized, because that is not the kind of thing that's typically regulated so directly by, like the intention to be like, I want to help this person deal with pain. So kind of cool. There was also a study that showed among people this group at Dartmouth has developed what they call a nonverbal, non-invasive diagnostic technique using basically EEG over the visual cortex that was 87% accurate in predicting whether or not somebody was on the autism spectrum. And so this sort of is derived from differences that have been observed and described in the brains of folks diagnosed with autism in how they process visual signaling or visual stimuli, along with a bunch of other kinds of sensory stimuli. Like oftentimes folks on the spectrum are hypersensitive to sensory input in general, like light touch, for example. And so this is potentially quite useful because the average age of diagnosis for autism spectrum disorders is about 4 years old. And oftentimes it is diagnosed almost exclusively behaviorally, like just by observing the child. There are some, specially trained physicians who can recognize it at much younger stages of development, like 18 months, or even younger in some cases. But that's certainly not the norm. And so this could potentially be quite useful in recognizing it earlier and responding in the unique ways that the unique brain of somebody on the spectrum would benefit from. And so what's cool about this, though, is that they basically showed that there are a bunch of differences in the way sensory processing is performed in folks on the spectrum, but one of them is how they toggle between visual dominance by our two eyes, right? And so to make this a little bit clearer, if you present a visual stimulus where each eye is receiving a different visual stimulus, so for example, like red checkerboards versus green checkerboards, what we sort of subconsciously do is we toggle between focusing on either one of those. It's called visual dominance. And so that is a totally automatic thing, and you don't necessarily have to like consciously be like, okay, what's this one? What's this? Of course you can, but it just sort of happens naturally. And it turns out that folks on the spectrum tend to take longer to toggle between those two sources of visual stimuli. And this is thought to be derived from differences in the GABAergic signaling system, which is also associated with why they have oftentimes differences in sensory sensitivity. Again, like sort of like sensitivity to light touch or like light stimulation, sound, and stuff like that. And so, so this group were able to couple EEG, like just measuring responses in the visual cortex, to this visual toggling task, and were able to predict whether or not somebody was on the spectrum with 87% accuracy, suggesting they might be able to use it as a diagnostic to recognize, again, whether or not somebody's on the spectrum much earlier, before we, humans even develop speech, or in some cases, if somebody is completely nonverbal, which can be the case in some adults on the spectrum. There's another one, but maybe I should just go live on Twitter now, and then maybe we can talk about it. It has to do with testosterone, the effects, the perceived effects, the long-standing perceived effects of testosterone on moral decision making. The short story is that it's more complicated than we thought. The accepted wisdom was that high testosterone levels correlated with more sort of utilitarian, consequentialist is what it's called, moral decision making, meaning if you have the choice between saving more people, but to do so you have to injure somebody versus just avoiding injuring somebody, the long-standing wisdom was this harkens back to the classic trolley problem or moral dilemma. And I'll just describe it. So basically, imagine you're standing on a bridge, on an overpass that stands over a train, and there is a bundle of 12 people tied together that will inevitably be hit by a train that you can see coming. and you can most certainly stop that from happening, stop the train from hitting those 12 people by pushing somebody over the edge of the bridge, interfering with the ability of the train to hit the 12 people. So you will therefore have saved 12 people, but have actively killed one person. And so, this moral dilemma can be tweaked in a bunch of different ways to sort of feel the contours of moral decision making in different people. But fundamentally, what it speaks to is the difference between utilitarian decision-making or consequentialist decision-making, which is again saving the 12 by sacrificing the 1, versus what's called deontological decision-making, which is it is unethical in any circumstance to directly harm anybody, in which case you would not push the person over the bridge, thereby saving the person, resulting in the fatality of those 12 people, but you did not take part in what would be considered an unethical decision, right, by pushing the person over. And basically, this group found that it's kind of interesting that supplementing with testosterone did not result in elevations of that consequentialist, save the 12, greater good decision making. However, people with naturally higher levels of testosterone did tend to be predisposed to that utilitarian decision making. Interestingly, psychopathy tends to correlate with high levels of natural endogenous testosterone levels. Basically the picture they're painting is that it's not like testosterone just drives us all to be like, Vulcans or whatever. They drive us all to be completely, consequentialist, unemotional, automatons. But there does seem to there is at least a correlation between levels of testosterone and moral decision making. This was a group at the University of Texas at Austin. So it's an interesting study. Immediately, what I first thought of when I started reading this study is like, wow, they were just giving people testosterone. That's pretty wild. And I didn't actually remember to note the dose of testosterone, but it's a hell of a thing to just like take some testosterone. Of course, it's just one time, I would imagine, and so it wasn't like they, were like on a cycle. but pretty interesting. Ooh, my volume is up way too high, isn't it? Okay, why don't we go live on Twitter now? Hello, everyone. My name is Ian McLaughlin, and I'm a PhD candidate for now at the University of Pennsylvania. And, you know what? I recognized towards the end, right after my defense, that I had been living a life that was almost entirely foreign to me before I started my graduate program. And it was most notably indicated by the fact that I had basically stopped reading fiction. And like before I started my graduate school, or started at graduate school, I read a ton of fiction. In fact, science fiction was probably the reason I went into science. And so I was like, I heard about this book that came out that has a neuroscientist as a protagonist. Hello, what's up, Khalid? So I just like picked it up. I was out on a walk with the girls, with my baby and my wife. And I was like, we walked by a bookstore, so I got this book. I don't know this guy. I'm not like, advertising for him or anything. But it's called Recursion. And I'm about a third of the way through or so. And it's good. I mean, it's a good book. He's a good writer. It's very sort of simple. It's not like, it's very easy to read, I should say. Unfortunately, there are 2 myths already in the book that he's accepted. But as every science fiction reader, every avid science fiction reader notes, there's a rule to reading science fiction if you want to enjoy it, and that is suspension of disbelief. And so, but just in case you're reading this book, it's a good book. You should, at least so far. The 2 myths are that when we die, DMT is released by the pineal gland. No evidence that that's the case. In fact, there's no evidence that DMT is released at levels that are important whatsoever in the human brain. And then, what was the second one? Well, I guess that's that, and that was the main one that irked me. And in all fairness, the vehicle for the myth was not the neuroscientist character in the book. It was actually a tech, somebody that was clearly modeled after like Mark Zuckerberg, who was funding her research. That was the vehicle for the research, or the vehicle for the myth. Anyways, it's a good book. It's called Recursion by Blake Crouch. All right. Hello, Elizabeth. Have you read The Gene? I'm not sure which book that is. Is that the one by no, I haven't. I don't think I have. If that's a recent book, I haven't read it. Will there be flying cars and droids? Yeah, I think so. I mean, well, flying cars, I actually don't know that there would be flying cars. I mean, I'm, just about a PhD in neuroscience, and so it's not like I study flying cars. I'm not an engineer. But if you just think about the sort of the like logic or the utility of having flying cars, it just seems like a mess. Like, I don't understand how that would be superior to just having cars, better cars, like cars and better urban design or better, traffic engineering. It's just like, if you would have to think about like travel in 3 dimensions rather than the, let's say, 2 dimensions that we currently, just moving, in a linear direction. I feel like that the advantages would not outweigh the disadvantages. How's your family? My family's doing great. In fact, you may or may not hear my baby. Oh, actually, I have a sample for you guys if you want to hear it. So she has developed a new skill. And so she's also in the room, so she might react to hearing herself. But here, check this out. That's right. She can say da, 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 da. And she says it all the time, whenever possible. And she might say it imminently. Anyways, we're doing great. Thank you for asking. The 3 of us had a date last night. We went out to dinner. So the baby girl is doing very well. Thank you for asking, Warrior Grandma, and SD Beach Mom. Oh man, I'm jealous. All right, and thank you for the super hearts, Elizabeth. That is super generous of you. What's up, Zaina? Yeah, I mean, like, I recorded that and I was like, yes, she's finally saying dad, and now that's all she says. Like, it's just whenever she starts talking, that's what she says. There she is. She is a cutie. What color is my underwear? Well, Emmanuel Macron, everybody knows that the French president doesn't wear underwear. So, trick question. We can't figure out drug in 2 dimensions. How will we do 3? Hey, and is there such a thing as brain farts? Hey, what's up, Diane? Well, sure. I mean, the term brain fart, that's not a term that we use in neuroscience formally. And it's, used to refer to different things. Generally speaking, I think that it's used to refer to either when we forget a word, when we know that we are familiar with the correct word, but we forget it in the most, least opportune moment. And that is actually a pretty well-characterized syndrome. It's kind of similar to déjà vu. Presque vu, I believe is what it's called. But basically, it's tip-of-the-tongue syndrome, where you're like, I know this word. I've said it a million times, and I just cannot dredge it up at the moment. And there's some interesting neurophysiology behind that, because the way that language works kind of reflects some of the ways that movement works. And I love the example of how movement works because it's so illustrative of how messy and disorganized our nervous system is. So, for example, right, you look at my hand and I'm moving single fingers, right? I'm not necessarily, single fingers. And so the way that neurophysiology works is that a certain component of my neurophysiology is sending signals to my hand. And those signals are, move your fingers. Move all the fingers, right? But of course, I'm not moving all of my fingers. I'm only moving my index finger. And so the way I'm able to hone in on specifically my index finger is that another part of my neurophysiology inhibits all of the other fingers. And so you're getting an all green light to all fingers. And then you have another system saying, wait. Not all the fingers, just shh, just this one. Right, and that's how we move. It's essentially like a competition of a bunch of different signaling systems, and one of them eventually wins out, makes it through the gauntlet of inhibitory signaling. And so when we're speaking, the words that we end up selecting also are a byproduct of a similar type of process. And so when it comes to that tip of the tongue syndrome, where you know the word, but you just cannot remember it in that moment, it's because your brain, part of your brain, has determined that we've found the right word. It is oven, right? That's the word that you mean to say, when in actuality, you're trying to say obscure or obscura or something that's kind of similar to oven, but it's not the same word. But the problem is that your brain is inhibiting obscura and saying, no, it's oven. You want to say oven. And so it's just another example of how messy, disorganized, and in many cases suboptimal our nervous system is, despite the fact that it is the most versatile and comprehensive nervous system that's, as far as we're aware, has ever existed. Do you do research on cannabis? I personally do not do research on cannabis. However, we do research on tetrahydrocannabinol, THC, the principal psychoactive component of cannabis. It's actually pretty difficult to study. Well, it's difficult to study THC. It's quite difficult to study cannabis legally. And you have to get permission from the FDA and then the DEA. And by the way, what happens when you get that permission, or a component of getting that permission, is the DEA comes into your lab. In our case, they were holding, I don't think they were AR-15s. They must, I don't know, maybe they were the military version of the AR-15, but they were big guns. And it's just sort of like, oh, this is not a standard operating procedure. You don't typically see those giant guns in the lab, but, they're just coming in. It's just sort of standard for them, I guess. It's just part of their operating protocol. But anyways, it takes a long time to get permission to study those drugs, because they are Schedule I drugs in the United States, as illegal as a drug can be. Regardless, we study a bunch of different drugs that are hard to study, including cocaine. Ethanol and nicotine are not the hardest to study. In fact, you can buy amounts of nicotine that are shocking, that are actually like mortally dangerous, from chemical supply companies. Anyways, we study those. We study opioids like morphine and buprenorphine. Do we study? We haven't studied. Those are the two opioids that we've studied. Naloxone, we work with, and then THC. All right. Is depression curable? Is it curable? Yes. Depression, just like all psychiatric conditions, are a byproduct of a unique pattern of brain activity. And that pattern of brain activity obeys the laws of physics. There's nothing magical, there's nothing ethereal about anything that emerges from the brain. It just so happens to be astronomically complicated. So complicated that we don't even know all the rules yet. And so, for example, if you're watching a football game, be it American or what the rest of the world calls football, and a player makes a weird decision. Well, if you know the sport, you know all the rules of the game, and so you might be able to understand this is probably why that player made that odd decision, right? This is why that player was behaving in an aberrant way, why that American football player was in a part of the field that wasn't very active, or, when a soccer player passes the ball to somebody that, didn't really make sense. It wasn't optimal, but hey, the rules are the rules, and you can sort of interpret why those decisions were made. When it comes to the brain, we're still enumerating the rules. We know the basic rules, right? Like in soccer, don't touch the ball with your hand unless you're the goalie, right? But there's still other rules at a more molecular, more microscopic level that we're still enumerating. And so that's why we haven't cured conditions like depression yet. But we do understand a lot of the game here. And we are now in the process of honing in on those more microscopic components. In fact, part of my thesis project, my dissertation, was devoted to mapping out a part of the neurophysiology underlying anxiety-associated conditions, both involved in addiction as well as independently of addiction. And so through that kind of work, years in the future, we'll be able to use that roadmap and say, this is precisely where in the brain we need to intervene. We don't need to just elevate levels of serotonin or elevate levels of GABA signaling, right? That's helpful, but it's not a cure. In the future, we'll be able to say, it's not just one neurotransmitter that governs anything in the brain, generally, anything that's important to us in the brain. Rather, it is specific clusters of neurons communicating with other specific clusters of neurons. Many times they have unique receptors that are not present anywhere else in the brain, or are present in far fewer, very seldomly in other parts of the brain. And so we can make a drug that targets those parts of the brain. And then, as psychiatric medicine becomes more sophisticated, we can couple that pharmacological treatment with more sophisticated, behavioral, psychological management of the conditions. All right. Irish but speaks from French. Well, I'm jealous. There is a Grand Lakes Marriott Orlando, Florida dispute resolution console, but we need more on, neuroscience bias training must be included in mediation. Oh, that's interesting. You said anything. Yeah, anything. Do you think this system and society is having a negative effect on children? Sandbury Sasquatch. Well, I think it's very easy to see something, and I assume you're referring to like social media and stuff like that. I think, it's very easy to see a new technology that has a transformative effect on how we interact with one another and just society in general, and say, and if it has any negative effect, saying, recognizing, oh, this is just intrinsically negative for us. But people said the same thing about the car, the automobile, when it was first released. Like, tons of people are going to die. And by the way, a lot of people did die. It took many years for us to institute laws like mandating, seatbelts, for example. We had to adapt to this new technology and the ramifications societally. And I think that's where we're at when it comes to the internet in general and social media and, just like online media broadly. This is still super new. I mean, I think because everything, time seems to move so much more rapidly these days, and like the news cycle is so rapid these days, it's easy to forget that, like, just 10 years ago, or a little over 10 years ago, social media didn't really play that significant of a role in politics. Like, it played a role, don't get me wrong, but it wasn't like, people were spending millions and millions of dollars, political candidates were spending millions and millions of dollars to try and get their face in front of you online. Now it's like, it's critical. And so, this is a very new phenomenon. And I grew up in a time when the internet was not ubiquitous. People had dial-up connections. It took you like, forever to get anything done on the internet. And it was like AOL Instant Messenger was like the hottest, coolest new thing. And so, and I'm not that old, I'm in my 30s, but like, I think we're still at an early stage. And in fact, I've been wanting to write a book about this topic for a long time, about like how does our mind adapt to this dramatic increase in bandwidth of our ability to take in and be bombarded with information, and also generate information and communication. But I don't know how to do that. I know how to write, but I don't know how to like write a real book. I don't know how to like talk to people who do that professionally. So if anybody knows, I would love to be put in contact with somebody. Suicides kill how many young ones even? So suicide is certainly a growing challenge in the United States. And I'm not as familiar with stats outside of the United States. But yeah, gosh, I can't believe I'm forgetting. I actually presented those stats in my defense talk, but I presented a lot of other stuff too. Anyways, there's been a dramatic acceleration. And, suicide is one of these things that is so multidimensional that it's not like it's any one thing, right? It's not like, oh, well, this increase in suicide also correlates with far fewer pirates roaming the high seas, right? It's not like we need more pirates on the high seas to mitigate levels of suicide, right? Like, nobody would make that assertion. And so there's a lot of correlation that one can draw, right? Society is changing extremely rapidly. But, there's economic factors, pharmacological factors. Of course, there's a huge addiction crisis in the United States. There's, demographic changes. People are moving from rural areas to urban areas. And, so I think there's just so many different, mechanisms of societal evolution, and just attributing it to like the internet or social media, I think is myopic. I'm certain it plays a role, but oftentimes my instinct, this is speculation here, my instinct is that, much like with many things, the internet acts as an amplifier of other things, right? So it's not like, Discord never existed in the United States before. Like I was watching, I was listening to a biography on FDR's political experience, right? And oftentimes we talk about FDR. So my grandparents were in the United States, lived in the United States during FDR's his very long presidency. My grandfather fought in World War II. And it's long enough ago, enough people were not alive during FDR's presidency, that I think it's really easy for us to forget just how tumultuous a time that was. I mean, there was a veterans rally in Washington, D.C. that had to be put down by a militarized police force headed up by Douglas MacArthur. And people died in D.C., veterans. And there's just a bunch of different examples of that. There was a plot to overthrow FDR headed up by fascists in the United States. Anyways, I think it's easy to overlook how much societal friction there has been in the United States for a very, very long time. And now we have the internet, so it's so available. It's, we see it every single day, literally every day. And I'm not trying to make the argument that like now is no different from the past. Of course, it's different, but all I'm saying is that instinct to suspect that the internet is the vehicle for this tumult, I think is myopic. Are we antennas? Well, we're more than antennas. I suspect you mean, are we receivers of information, receivers of stimuli? And in a certain sense, we are, right? That's one of the most wonderful things about having a human brain, is that we can receive so much information and adapt to it, and we're versatile in the kinds of information we can use. But we're much more than that, right? We reproduce. We can experience this whole wide cornucopia of emotional states, which is part of the best part of being human, in my opinion. So yeah, I mean, yes, and who is Joe Rogan for 500? First picture of a black hole, very cool, right? I don't have much to say on that apart from, yeah, super cool. And how cool is it that the existence of black holes was predicted decades prior to the first image of black holes? Another testament to how cool the human consciousness can be. All right, they wrap it up as a psychiatric emergency, would rather do socioeconomic and psychosocial autopsy. Yeah, sure. I assume you're referring to suicide. I'm still so sad and have tried all the medications. Oh, Jackson, sorry I missed your initial comment. I'm a self-published author. Oh, cool, Nabil. Yeah, that's something I've been thinking about, but again, I haven't had enough time to look into how that's actually done. I mean, I know you just put your book on Amazon essentially, but I don't really know what the benefits and disadvantages are to doing that. I would love it if you could learn me some stuff on that. Okay, can acetaminophen help emotional pain? If I assume you're referring to the dorsal anterior cingulate cortex is associated with both physical and emotional pain. So Grace Lynn Lato, it's an interesting topic. And in fact, I think one of the things that pretty much every student of psychology in the United States has to learn is the Cannon-Bard theory of emotion. And I don't want to go too deep into it. I think its utility in understanding emotional processing at a neurophysiological level is limited. But there are some very useful insights from that model, which was essentially, rather than just brain states dictating body states, like if you are upset, your body feels bad, and that's the only relationship, it's a one-way relationship. Rather, body states and brain states influence one another. And so if there's some damage to your body and you're experiencing chronic pain, that influences brain states, and that's true. And conversely, if you are depressed or you're lacking sleep or you're chronically stressed, that can generate, there are ramifications for that peripherally, where you can experience psychosomatic pain or, that sort of changes in body states that are exclusively driven by changes in brain states. And so when you say, can acetaminophen help emotional pain, and when you say emotional pain, I'm not 100% sure what you mean by that. I mean, that is a thing for sure, but there is an emotional component to pain, meaning, when somebody's in pain, they have an emotional reaction to it. Side note, I don't know if you can hear my daughter, but she's saying dada right now. By the way, she says it when I'm not around too. It's not like she's just calling for my attention. Although I like to pretend that she is. Anyways, there is an emotional component to pain. But then there's also just the purely somatic sensation of damage, component to pain. And the emotional component to pain is extremely important. And in fact, that's part of the reason for why opioids can be very helpful in elevating quality of life in people who are suffering. However, yes, right, if you can mitigate levels of pain that one is experiencing from a bruise or from a fracture or whatever, derived from the inflammation of that injury using something like acetaminophen or any of that sort of class of drugs, then yeah, that will help to free your consciousness of some of the fetters of that pain, if that makes sense. But it's not the same. It's not the same effect as like an opioid on the emotional system. Opioids have a direct effect on emotional signaling, and a drug like acetaminophen does not. So it's a much more indirect Cannon-Bard like mechanism. All right, Ray, we have a caller. What's your name and where are you calling from? Whoa. Do you think that was like a Demogorgon? That was wild. Oh, well, the dude's name was Ghost NU, so maybe it was a ghost. That's kind of cool. Interesting career. Thanks for the answer. I'm a biology and psych double major, so the overlap interested me. Oh, man, yeah. Well, I mean, we could go deeper into what distinguishes the pharmacology of, an analgesic like, hydrocodone, which is sort of like a kind of a standard opioid analgesic versus something like acetaminophen or, ibuprofen or naproxen sodium. But yeah, I mean, I think my wife is trying to distract me with my baby right now, and it's working. But suffice it to say that you could make an argument that yes, mitigating inflammation-associated pain will yield benefits emotionally and psychologically. All right, we are getting another call, this time not from a ghost. So hopefully we'll be able to communicate. So Cory, I assume is your name. Where are you calling from?
I'm calling from Seattle, Washington.
Cory from Seattle, what's on your mind?
Yeah, I want to know if MK Ultra mind control really works. Like, can they really manipulate your brain from a distance or from a computer with waves?
Right. So, okay, without going too deep into like what MK Ultra was and that whole thing.
Yeah.
So
scary.
Right. I mean, so it was a wild time back in the day. And in fact, if anybody's ever seen the TV show Stranger Things, it's actually based on it's a conspiracy theory that there was this effort to try and do just that, to try and develop techniques to enable people to develop sort of paranormal abilities, psychological abilities. So, okay, MK Ultra was not the same thing, but similar. So, and in fact, by the way, this book, Recursion, which is just science fiction, plays with that theme a little bit. In any case, is it possible to manipulate somebody's consciousness using either drugs, as was the case in MK Ultra?
Yeah, I think they use drugs with it.
Yeah, I believe it was LSD or psychedelics. So the question is it possible to manipulate somebody's consciousness doing that? And then more broadly, can you manipulate somebody's consciousness using other things like stimulation, like maybe electrical stimulation or maybe magnetic stimulation? So stepping back at a bird's eye view, yes, it is possible to manipulate somebody's consciousness using it's not that simple, right? So it's possible for me, let's say Cory, you were here and we went to my lab and I gave you some cocktail of medications or drugs. I could definitely manipulate your psychological state rather effectively, right? What you could not then do is develop the ability to influence my psychological state remotely, right? So that sort of metaphysical component to what people were interested back in the day and the sort of the Stranger Things kind of concept, there's never been any evidence that that's possible. And so rather it is just using either pharmacological agents like LSD or any of a variety of drugs coupled with
marijuana.
So coupled with other behavioral things like subjecting somebody to isolation or essentially torturing them.
So are we kind of like Bluetooth?
Are we kind of like no? So I mean
antennas.
In a way, in that we are social primates, right? We evolved to exist in tribes and interact with each other socially. And so, we are receptive to being manipulated along those lines. But it's not the case that we have some component of our brain that is like wirelessly receptive to signals that other people's brains are generating that have nothing to do with like speech or personal interaction. Right? Do you see what I'm saying?
Can they hook computers up to us that give us forced speech?
I'm sorry, say that again?
Can they hook like computers up to you that gives you forced speech with the mind control?
So the short answer is today, no. There is no system that would enable, me, let's say, or some mad scientist to control your behavior using, computer implants. But particularly given efforts like that of Neuralink, Elon Musk's new company, or there's a variety of other whole brain computer interface companies, the goal of which being to enable us to interface with computers far more smoothly. upon the inception of that technology and integration into our biology, yeah, it would be possible. But that is still, as of today, science fiction.
Okay. Thank you.
Yeah, interesting topics. Thanks for calling in, Cory. All right. Ian, your scope should have the entire Periscope on it. Shows the lack of intellect on scope. Oh, people are busy. I don't think it's just Periscope or Twitter that is an example of that. Not everybody's interested in the topic. I get that. I try and make it so that we can talk about anything that somebody's interested in. But I wouldn't use that as an indictment of people in general. Do flat Earth believers have something wrong with their brains? No, I don't think so. I mean, apart from their belief that the Earth is flat, but that's not a brain disease. No, I mean, I would love to use the flat Earth phenomenon as a case study of how it is that the internet can inflict some cognitive, I wouldn't call it damage, but influence upon us that is undesirable. Mario or Sonic? I was a Mario guy. All right. Artesia. That's the first video game I ever played, was Mario. Artesia, what's your name and where are you calling from?
How are you today?
What's your name? I'm sorry?
Do you believe we're in the same dimension? Or do you believe we're in a different dimension at this time?
Okay, I guess I missed your name. But where are you calling from?
California.
Artesia, okay. From California. So I'm not a physicist, but oftentimes people invoke sort of spooky physics to explain aspects of our consciousness, like déjà vu, for example, or dreams. I've never seen any evidence to suggest that any of us exist on any other dimension apart from that which we encounter every day. So unless you're using the term dimension to refer to something other than what physics refers to it as, I have no reason to believe that we do exist elsewhere.
Okay. Do you believe in a paradigm shift?
Well, paradigm shifts happen all the time, sure.
Okay. Now, let me add this right. You're the brain guy here. Now, is it really 2019?
I mean, it's sort of an arbitrary point at which we began counting years. Different cultures have different, numbers of years. In China, that it's not 2019 according to more ancient Chinese dates. The Jewish tradition or Hebrew tradition, it's definitely not 2019. So it's just.
Okay, so you believe like the humans believe?
I would believe like humans believe.
You believe like the humans believe.
It's tough for me to believe anything else because I am a human. But it feels like you're driving towards some point. So why don't you get there?
Okay, let me clarify this. The Bible is only 6,000 years old. Am I correct?
I'm no expert on the Bible.
Okay. The Bible put the timeline and cut it in half. They wiped out billions of years of history and started right there, 6,000 years ago with Constantine. So, when I'm saying everything that even you were taught was a false doctrine of Greeks and Romans.
I don't study many things from the Greco-Roman era or antiquity. Most of what I study is discoveries that have been made in the past, 50 years.
Mm-hmm.
But I think I sort of get at what you're arguing, which is a lot of maybe scientific thinking or philosophy is derived from philosophy that emerged during that era. Is that sort of what you're arguing?
Okay. No. What I'm trying to say is that when they cut the timeline, the Europeans put themselves on top of the throne. Before that, it was just melanin people. In order to conquer people, they gave them a god. And then everything that you know about science and history actually came from the black man. Everything.
Okay. Well, I mean, listen, it's an interesting story. It's one that I am totally unfamiliar with. And so I don't really have much substance to offer you back. But listen, thanks for calling, Artesia. And I appreciate the critique. All right. I think I know where that was coming from, but it's just not my area of expertise. Does lamotrigine or lithium prevent you to feel the effects of ayahuasca? All right, interesting topic. So just so everybody's on the same page, lamotrigine is the sort of the name that you might be more familiar with is Lamictal, which is an anticonvulsant drug that's used usually to treat epilepsy or seizures. Lithium is a pretty old drug, actually, and it's used as a sort of mood stabilizer, oftentimes to treat bipolar disorder that's rather severe. What's wild about lithium is that we don't know exactly how it works. We have some good theories. It likely just alters the way that certain ions flow in and out of neurons, which is a sort of very foundational component of how neurons fire impulses. So now, will these drugs alter or prevent you from experiencing ayahuasca? So again, so everybody's on the same page, ayahuasca refers to a kind of traditional psychoactive beverage that was created, or it's derived from cultures in like Peru and parts of Brazil, I believe. And basically what it entails is the use of most frequently a vine called the Mimosa hostilis. That's then, you make a tea out of it. You grind it up, you make a tea out of it. And then you couple that with what is an MAOI, or monoamine oxidase inhibitor. Arentes Jackie. Oh, cool. You're from Brazil. That's awesome. I've been wanting to go to Brazil for a long time. Growing up, a lot of my friends were from Brazil. Best food, definitely. Well, among the best food. Nothing beats lobster, right? Anyways, ooh, that was probably so loud on the microphone. Sorry. Okay, so again, you're coupling this plant with another, usually a plant. Oftentimes, Syrian rue is what's used. That contains monoamine oxidase inhibitors, which, as the name implies, inhibits an enzyme called monoamine oxidase. And the result of that is that certain dimethyltryptamine-containing molecules, including just dimethyltryptamine, are able to escape your gastrointestinal system, not get gobbled up by monoamine oxidase and other enzymes, get up into your brain, and induce psychedelic hallucinations. Okay, so now we have all the different drugs on the board here, and now we can talk about pharmacological interactions. So, well, first of all, just in the interest of being prudent, if one is being treated with lithium and Lamictal, it's probably not the best idea to ingest drugs, the pharmacologies of which have not been completely established. Ayahuasca has been consumed for a very long time, but it's not been studied by modern neuroscience, neuropharmacology, for a very long time. And MAOIs, monoamine oxidase inhibitors, they're a very significant pharmacological effect, right? And here's why. Particularly if somebody is being treated with Lamictal or lamotrigine, that means that somebody's quite likely predisposed to seizures. Not 100% necessarily. Sometimes it's used to treat bipolar disorder too. But if one consumes an MAOI, that puts the person for a period of time at risk of experiencing seizures. And that's because MAO, the enzyme that, again, would gobble up the DMT and 5-methoxy-DMT that's present in the ayahuasca, it also breaks down a bunch of other molecules that are not pharmacological, but or have no pharmacological effects as a result. And so if you were to eat steak or any tyrosine-containing drug, or any tyrosine-containing food, that can induce seizure. And so when somebody does ayahuasca, generally, if they do it responsibly, they know that they have to stick to a certain diet. And so because, Lamictal can be used to treat focal seizures or tonic-clonic seizures, I would just be very concerned about that. But then, even more broadly, right, folks with psychiatric conditions like bipolar disorder, mood-related conditions, generally speaking, it is not the best idea to consume any hallucinogenic drug, really most mood-altering drugs, because you have a unique brain state. At least for a period of time, you are sort of vulnerable to emotional volatility. And so, while it can be the case that some psychedelics might be therapeutic in some cases, right? So, right now, MDMA, it's not technically a psychedelic, but it has some hallucinogenic properties, as well as psilocybin, which is definitely a psychedelic, are being evaluated for potential utility in clinical settings, psychiatric settings. That is in a very controlled environment, and it's being administered by somebody with pharmacological training. And And, there's no evidence to suggest that, any of these drugs are generalizable. Like maybe psilocybin might be beneficial, but mescaline would not be. Those are both psychedelic drugs, but different different chemical structures. And so all of this to say, I wouldn't recommend it. It will, now, just to get to the basic part of your topic, will these drugs prevent any pharmacological or psychoactive effects of ayahuasca? Probably not. But they will definitely change the pharmacological effects of the drug, and make it, different than it would be otherwise. And it is definitely ill-advised to terminate treatment of the medications just so that you can experience ayahuasca. It's definitely not a good idea. Are you Neil Tyson's brother? No, I'm not. But he is an inspiration, that's for sure. All right. How many calories does the brain need on a daily basis? Most vital nutrients. It's an interesting topic. CWB, I feel like I recognize your handle. So I can't tell you a precise number of calories. What I can tell you, however, is that the brain consumes about 20 to 25% of your caloric intake, which is remarkable if you think about it, right? We use calories for a variety of processes, biochemical processes, and then, of course, just moving muscle, like just sustaining a heartbeat, or moving your biceps, right, or moving your leg muscles to enable you to walk. That takes caloric energy. And the brain is just sitting there. It's not like physically doing anything. It's not moving. Of course, it's generating action potentials, which is very metabolically intensive. And so about 20 to 25% of your caloric intake. Now you can calculate your base caloric sort of, baseline needs, meaning if you consume less than this number, then you will be at a caloric deficit and you'll begin burning fat stores. Your base metabolic rate is what it's called, and it's pretty easy to calculate. I mean, it's an approximation, of course, but it's derived from your height, your age, your level of physical activity apart from any exercise, and it's probably somewhere around, depending on your size, maybe a 1,300 to somewhere around there. Of course, again, it varies according to size and age and gender, or sex. And so but the brain demands quite a bit of your caloric intake. All right. What's your favorite Ukrainian soup? I don't know a lot of Ukrainian soups. I don't know if borscht is made in Ukraine. I know it's made in Russia. And they're not the same country, but if they make borscht in Ukraine, that would probably be my favorite. Welcome to a scientist taking his value time to educate and answer questions by the uninformed. Creative group, that's very sweet of you, but I wouldn't call anybody in here uninformed. It's just, this is a specific topic that I've devoted my life to studying, and it's a privilege, and not everybody gets to study it. So I guarantee there are plenty of things that everybody in this room knows that I am completely unfamiliar with. How do I hallucinate? Cregan. It's an interesting question. So at the most basic level, the way you hallucinate is there being a distinction between sensory inputs. So in other words, information that your sensory system is delivering to your brain, your visual system, your auditory hearing system, your tactile, your proprioceptive, your vestibular systems, and how you perceive your sensory environment. So there's just a breakdown between those two things. And that can happen via a variety of different mechanisms. And in fact, one could make the argument that visual illusions are in some instances a hallucination, because, again, that it is derived from a discontinuity between what your senses are delivering to your consciousness and how your consciousness is perceiving your sensory environment. Now, of course, you can induce hallucinations via a variety of mechanisms. Probably the easiest way is to administer a hallucinogenic drug, but you can also experience hallucinations derived from psychiatric conditions, like, of course, schizophrenia, and in some cases bipolar disorder, or just psychosis that is not necessarily schizophrenia. A lot of people experience psychosis at least one time in their life. And then you can also experience hallucinations if you have a traumatic brain injury. You can experience hallucinations while sleeping, or while sleeping during dreams. Those are hallucinations. But then also when either falling asleep or waking up, you can experience hypnagogic hallucinations, and that is because your brain is in this sort of transitional state between sleep and awake. But then at a sort of a fun, kind of whimsical level, our perceived reality is a hallucination. This is an argument that Anil Seth makes. He's from England, somewhere. He's a neuroscientist, and yeah, I mean, there are so many features of our sensory systems, particularly the visual system, that are the byproducts of curated signaling that results in a depiction of reality that is not actual reality. And in point of fact, we live, our existence is in the past, right? What we experience as the present is not actually the present. It's the past. Either our immediate sensory delivery system, where the quickest sensory system that we have, the most accurate depiction of now, is our visual system. And of course, that is derived from photons crashing up against your environment all over the place, and then eventually crashing up against your retinal, your photoreceptors. And that's very fast. That whole process is very fast. Speed of light, of course. But once it hits your photoreceptors, now you're at the speed of the nervous system, which is dramatically slower than the speed of light. And so as a result, your visual system is tricking you into perceiving everything that you're observing as happening now, when in reality it happened in the past. Pretty loud, right? That's why I have déjà vu. We can talk about déjà vu. In fact, I have a podcast. It's called Wired to be Weird, and it's on iTunes and Stitcher and Spotify and etc. And I have episodes on déjà vu. We went deep. I didn't expect it to be as interesting as it ended up being. There's a good amount of research on it. Can you hear? Bad. Hello from France. Hello from Philadelphia. And so we can talk about déjà vu. But here's what I'll say without you wanting to talk about something specific about it. First of all, we have a pretty good idea neurophysiologically of what's going on when somebody experiences déjà vu in the brain. We have a good idea of what neighborhood in the brain is generating déjà vu. So you don't have to talk about multidimensional existence. You don't have to talk about membranes of the universe bumping up against each other. It's both more mundane, more personal, but also more remarkable because it reveals a lot about how we perceive the universe. Damn lonely here on YouTube. Yes, I am also live on YouTube. I don't know if people enjoy that interface more, but you can check it out. All right. Have you ever wanted to be a neurosurgeon? Yes, there was a period where I wanted to be a neurosurgeon. It was a brief period. But, yeah. McLaughlin, let Meek Mill know we will be pulling up on Philly. Yeah, I'll call him up after this. Okay. You hate déjà vu, really? How long have you been at Scope? I remember when you started, but don't remember a baby being around. Yes. Well, so she's about 7 months old. So, yeah. So that is a new addition. Is melatonin everyday safe? Would too much be the same as sleep medication causing Alzheimer's? Interesting topic, Eric Turner. So, first of all, there is indeed a correlation between certain medications that are sometimes used for as sleep aids, benzodiazepines, a correlation between that long-term use of that family of drugs and dementia. But again, I keep saying correlation because it is not a causative relationship. At least they have not established that benzodiazepines cause Alzheimer's disease in any way. And here's why that is particularly important here, or particularly important. And that is that not everybody consumes benzodiazepines, right? There is a certain subset of folks who are, for whatever reason, prescribed benzodiazepines. And at least in the United States, there has to be a reason that they are prescribed the benzo, right? Either they were prescribed a long time ago and they're being treated for some mood-associated condition, or they're treated less long ago, but not today, for a sleep-associated condition as a sleep aid. They are no longer used for that reason. But as a result, those are two specific patient populations with brain-derived difficulties, right? Either they have a mood-associated psychiatric illness, or they have sleep problems. And we know sleep deprivation is definitely associated with an increased risk of dementia. And so it could just be the case that benzodiazepines just happen to be a marker of somebody who is at risk of Alzheimer's disease. And it is not actually causing the Alzheimer's disease. So it's worth being a little bit nuanced about that topic. Now, melatonin. Melatonin is, the short story is that it is widely appreciated as being pretty safe. And there have been studies as to how any potential hazard of melatonin. And there have not been there's no evidence to suggest that it's detrimental to health in any way. Now, when you say high doses, I mean, there's a wide range of doses of melatonin you can take. Usually when somebody gets it from the supermarket, it's like 1 milligram tablets, but you can get up to like 5 milligram tablets. But suffice it to say, there's no evidence to suggest that there's any hazard associated with regular melatonin use. However, I would submit to you that if you are using melatonin regularly as a sleep aid, there's no evidence to suggest that melatonin is beneficial in that way or useful in that way. The most supportive evidence of the utility of melatonin suggests that it's actually good for correcting jet lag or, a disruption of your circadian rhythm and sort of correcting for that. And it's not a sedative. Like, it won't make you sleepy all of a sudden unless there is some sort of disruption of your circadian rhythm. At least that is the evidence as of today. Those terms, whilst time is continuous. Please explain how that hypnotherapist put University of Texas football players under. I didn't see that. Sounds interesting, though. Is neuroplasticity a good thing? Rolling drum. Well, is it a good thing? Yes. Neuroplasticity is at the heart of why the human brain, or Homo sapiens, are so adaptive and so versatile. It is what enables our brain to change in response to environmental stimuli. Without neuroplasticity, we would be incapable of learning new skills. We would essentially just be born as, many other animals are. Other animals exhibit neuroplasticity. It's sort of an intrinsic feature of having a nervous system on Earth. But because of the complexity and the unique connectivity of the human brain coupled with neuroplasticity, we can adapt to almost any environment, essentially. And, we have yet to reach the potential of the human brain. It's also not the kind of thing that you have any say in, right? It's not like you can decide to not exhibit neuroplasticity or decide to amplify neuroplasticity without the use of some pretty exotic hormones. And amplifying neuroplasticity would not necessarily be beneficial in any way. So it's the kind of thing where it's like, I can't even think of can't even think of a core or of a metaphor. Yeah. So just don't worry about it. Don't think about it. It just happens. The brain takes care of that for you. It's gratis. Smart cookie, that girl. Are you going to stay and teach in PA or return home to Colorado? Either or. I love Colorado. Colorado's, I think, the most beautiful state in the U.S. I love Philadelphia, and of the rest of Pennsylvania that I've seen, it's also very beautiful. But it really just depends on where opportunities are. All right, we're getting a call from Diane. I don't know if this is the best time to take a call, but Diane, are you there?
Yes. Hi, Ian.
Hi. Well, what's on your mind?
We have a question about concussions.
Let's do it.
Okay. Junior's accident with the plane.
Yeah.
You saw that, right?
Wait, Junior's accident with the plane?
Yeah, he crashed 3 days ago.
No, I was not aware of that.
Oh, wow. Well, anyway, he has his own personal plane. They were coming in for a landing at Bristol, Tennessee for the race.
I see.
And he, his history of concussions.
Yeah.
Okay. Anyway, he was admitted to the hospital and released. And he's a broadcaster now for NASCAR.
Uh-huh.
So our concern is when he got out of the plane and it exploded, after everyone, got out of the plane, they were safe.
Yeah.
He fell to the ground. Okay?
Oh, I see.
The medics were there, but his legs were not moving. And that was my concern. What do you think about that?
Well, has he regained any function since then? Are you aware of how his treatment's been going?
Well, on social media, there's been nothing. He did not broadcast this weekend at Bristol. He's due to race next weekend at Darlington, South Carolina. And, everyone's like, quiet. My question is, after you've had multiple concussions and you fall to the ground, you have to look at the video. I'll send it to you.
Okay.
He fell to the ground, but he was talking. Everything, his brain was working, but the legs were not moving. That was my concern. Do you know anything about concussions?
Sure. Yeah. So I mean, as I know, but so everybody else knows, I'm not a physician, right? But so what that would suggest to me, if he was otherwise totally fine, but his legs were not responsive, that might suggest that there's an injury, but it might not be in the brain. It might be spinal. But regardless, any kind of jostling of the brain that severe will definitely, whether there was a concussion or not, can contribute to a cumulative amount of damage that we see most publicly in like the NFL, for example, where football players, they're not necessarily getting concussions every day, but they're getting their skull is getting jostled hard enough that there are subconcussive brain injuries. And so, just depending upon, whether or not there was a concussion or whether or not, there was a subconcussive injury, that'll reveal how likely it was that, there's some central nervous system damage in the brain derived from the plane crash. But if most of what was noted was just the legs were unresponsive, there might be a spinal injury there. That's what I would expect.
Thank you, Ian. I'll send you that video.
Yeah, please do. That sounds terrible.
Okay, listen. We want to see your daughter. Everyone's asking. We hear her. We want to see her.
I know. And I wish I could show you because she is absolutely adorable. But my wife and I made the decision that, we're probably, or her generation might be the last generation that has anything like anonymity. And, I feel like I don't want to make that decision for her before she can even say anything other than mama and dada, if you know what I mean. But I'm happy to share all the words that she says. I just want her to have the opportunity to be private if that's what she chooses to be.
I agree with you, Ian, but I love that face and that smile when you talk about your daughter.
Well, she's a cutie.
That's love.
We lucked out. But listen, it's great to talk to you, Diane. Thanks for calling in.
Okay, bye-bye.
Bye. Yeah, you have no idea. I wish, I would love to show you guys because she has the cutest smile. I'm so lucky. Hemispheric lateralization. Can you improve spatial reasoning if it isn't actually easy for you? So, Lonely Janet. Right. So these are two topics that are related, but may not be as directly as related as you might suspect. So, hemispheric lateralization is a term that refers to the fact that certain specific aspects of our mind, of our consciousness, of behavior are what we call lateralized, which doesn't mean that only one hemisphere, right? If you look at my brain, if I popped it out, you would see a line going right down the middle, the central sulcus, and that divides the brain broadly into two hemispheres. Now, not every part of the brain is bilateral. In fact, I study some of the very few parts of the brain that are not bilateral, not entirely bilateral or symmetrical. Anyways, so it's true we do have hemispheres, but generally speaking, they're symmetrical, bilateral. And there are certain aspects of our behavior and consciousness that are lateralized, meaning they're not generated by just one hemisphere, but there's more activity in one hemisphere than the other when we do things like, for example, speech. Language, is dominantly processed in the left hemisphere, although the right hemisphere is absolutely involved. And so, that's just one example. But when it comes to, and then there was a specific capability, spatial reasoning, right? Oftentimes spatial reasoning versus let's say creativity associated, processes like insight or making art, playing music, are oftentimes more closely associated with one hemisphere than the other. Oftentimes people will distinguish between being a more analytical thinker, right, where you define a problem and you work through a sort of meticulously arranged set of solutions or exercises, versus relying on insight or creativity, not being too rigid about the way you're thinking about a problem, but just sort of allowing you to sort of, percolate with the problem and then having an insight, right? These are two equally valid solutions to the problem of trying to solve a problem, right? Or solutions to a problem. And there's no evidence that one is superior to the other all the time. There is evidence that one is superior to the other in certain circumstances. But all of this said, is there a way to improve spatial reasoning? Yeah, I mean, the way would be to engage in activities that demand that ability, right? And so, this can be, for example, like one of the clearest demonstrations of spatial reasoning that I ever encountered during my education was in organic chemistry. And I'm not suggesting you do organic chemistry, right? Although it's a very interesting subject. I'm a huge fan of this subject. But the reason was, after the first semester of organic chemistry, that's when you memorize things like how to draw a chemical structure, or what an acetyl group is, versus an ester or whatever, like those types of just rote memorization. But then the second semester was synthesis. And that's when you had to imagine these chemical structures in space and how they would interact with each other physically. This is also true for biochemistry, where you have molecules or proteins interacting with other proteins in a 3D space. And, with some technology, we can now make animations of this happening. But generally speaking, to pass a class, you can't rely on that completely. And so you had to really engage in, imagining these chemical structures in space and how they interact. So that's just one very, and I hadn't developed that skill to the extent that I had assumed. And so you had to rely on this. It's a skill that we're all capable of. There is some evidence that there is differences in predispositions to that kind of thinking that distinguishes males from females. But it's not like necessarily it's not the strongest correlation necessarily, right? And, females are just as capable. And so, just like with many aspects of our consciousness, practice will make you better at this. And so rather than relying on other, strategies to remember a thing or solve a problem, try and think about it spatially. And, you needn't concern yourself too much with whether or not your right brain is being activated sufficiently. Chemistry class is exactly why I'm asking. Yeah, there you go. So I won't go too deeply into my own personal history, but when I was taking organic chemistry, there were some nights where my roommate and I both decided to major in neuroscience at the same time. And it was like halfway through college. And there were some nights where we would get intoxicated and we would literally talk about neuroscience, which is like the dorkiest thing you could do in college as a sophomore. But I have to say, it's never a good idea to study while intoxicated, because you're very likely going to forget everything you tried to remember. But having an altered state of consciousness was very helpful in enabling me to think about these structures in a way that was foreign to me, right? In a way that wasn't intuitive. And I suspect that just having that pharmacological inhibition or disinhibition actually was helpful. And I regularly use that. I also used I engaged in that line of thought, and I would apply that to anatomy, like imagining how muscles interacted with one another when, for example, contracting the calf muscle, or how the pectoral muscle it's not just one muscle, it's like a series of different muscles, and then neuroanatomy, like imagining in space how these different brain regions are arranged and how that form might also reveal insights about function. So I'm not recommending that you go out and drink with your friends before you study OChem, but there was some benefit to thinking about the relationships between these structures in a novel way. And maybe it's just meditation for you. Okay. Parietal lobes. Parietal lobes are definitely very important for spatial reasoning, but as a circuits guy myself, and it's funny, actually, during my defense, one of my committee members, as I was like talking about my project, he's a very like molecular biology, biochemistry kind of guy. And halfway through my exam, he was like, "Oh, so you're a circuits guy?" And I was like, "Yeah." Like, I didn't think I would have to say that, but it was just kind of funny. Anyway, that's how I engage neuroscience, referring to a whole lobe of the human brain as like this whole lobe of the human brain is important for X, Y, or Z. It's like that's like saying, you know, having a baseball stadium is very important for hitting the ball. It's like, yeah, I guess. I mean, it's part of it. Or baseball, you know, diamond. It's very important for hitting the ball. And it's like, that is like the biggest possible explanation for baseball, you know? Like, maybe it's even like, you know, yeah, it's important, but it's not what generates baseball, right? Like having the baseball bat and swinging the ball at a ball that was, or swinging the bat at a ball that was pitched to you. That's the more important part of hitting the ball, right? But I'm not saying that it's pointless. And at the level of human neuroanatomy, that's sort of where we're at, is general regions of functionality and how they interact with one another. So I don't mean to denigrate cognitive neuroscience, but at least for me, the language of the brain is at the level of neurons communicating with other neurons electrophysiologically. And so that's where I feel like we can have more profitable conversations. Not profitable monetarily, but more fertile conversations, let's say. Lego. Yeah, play with Legos if you want to improve spatial reasoning. Have you ever been choked by a ghost? I have not had the pleasure. But I don't know if you feel like you have. But there is, interestingly, a consistent hallucination that folks who experience sleep paralysis will describe. And that is the feeling of asphyxiation by a thing that is standing on their chest, standing or sitting or just pushing on their chest. They describe the feeling as being something like, an elephant sitting on their chest. They find it very difficult to breathe. And in fact, it's so consistent among folks with sleep paralysis, which I should describe, that is the experience of being unable to move while waking up. Not when you're completely awake. You feel like you're awake, but you're not entirely awake. It is consistent enough that many people who are experiencing sleep paralysis will describe the actual perception of a being of some sort sitting on their chest, whether it's a demon or some intruder, some person who they don't know. It's always very alarming, but there is that very consistent aspect to that hypnagogic hallucination, which is pretty wild, right? My sister's transgender is a real thing. It is destroying her family. I'm so sorry to hear that. Well, is it a real thing? Yes. I mean, there's no question that folks will say that they are transgender. I suspect what you're interested in is there a biological basis for differences in gender, right? This is obviously a very contentious topic. It's more contentious outside of neuroscience than inside. Oh, Jackie, yeah, thanks for hanging out. Your daddy face is quite endearing. Yeah, well, just talk to me when it's like 3:30 a.m. and she's refusing to fall. Last night, she refused to fall asleep at 3:30. I had to coax her back to sleep every hour. And at 3:30, she would not stop sticking her tongue out. And that was a problem because I rock her to get her back to sleep. And so her tongue would like move and it would keep her awake. It's just like, oh my God, just put your tongue back in your mouth. Anyways, yeah, no, she's delightful. Thank you. Thanks for hanging out, Jackie. Okay. So yeah, so transgender, gender in general is much more contentious outside of neuroscience than inside. And that is because there is enough evidence to demonstrate that everything from sexual attraction, sexual preference, your conception of yourself as masculine or feminine, it is extraordinarily complicated at a neurophysiological level. There is no part of the brain that a male has that a female does not have, and vice versa. it would be exceedingly difficult, if possible, but exceedingly difficult to distinguish. If you were to plop two brains in front of me, one of which was from a male, one from a female, genetically male, female, it would be very difficult for me to distinguish them or to identify them. It would be possible if you gave me some really fancy neuroimaging techniques, and even then, it wouldn't be 100%. Even the best, gender researcher, let's say, or sex researcher, neuroanatomical sex researcher, would struggle with that. The point I'm illustrating is that, it's not like there are very obvious neuroanatomical distinctions between male and female. Every year we find there's a new study that comes out that says, females have more intra-hemispheric connectivity, whereas males have more inter-hemispheric connectivity. And then there'll be another study the next year suggesting, that was actually just because the sample was too small or whatever. They were using an algorithm that averaged in this way, and if you do it, the point being that it's not as definitively demonstrated as it would intuitively seem to be. Right. So all that said, and we see all throughout the animal kingdom that sex, like male and female, that is very malleable. Right. I mean, not necessarily as malleable in all animals as others, but for example, the lovely clownfish. I learned this 2 weeks ago, or the anemone fish, as perhaps they like to be called, but they're clownfish. We all know them as clownfish. They're little Nemos. We know they're the orange and white lovely little fish. They are capable of moving from male to female. In that species, the females are dominant. And if you were to put two males in a tank together, given enough time, one of those males, the one that's dominant, will transition into becoming female and be able to reproduce and everything. So all of this said, like, if you are... if you are basing your response to a family member who has told you that they are transgender, if your response to them is contingent upon there being a biological substrate for that, for them being able to prove to you that, hey, this is the part of my brain that is what makes me transgender, then you're never going to be satisfied, and all you're going to experience is turmoil. Because that is just not how the brain works. It's not how human behavior works. It's more complicated than that. And if that person were in my family, let's be like, all right, cool, whatever. That's your path. That's your experience. Let's go get dinner. That would be my personal reaction as somebody in neuroscience. But general patterns don't say anything about a given individual. I guess I'm not quite sure what you mean by patterns, behavioral or neurophysiological. Is it true we only use a small percentage of our brain? Batty, XOO. Well, this is, I think, definitely qualifies as the topic that has come up the most frequently, and I think will never stop coming up. And it is an absolute myth. Well, it's a myth insofar as we are not limited to only 10% of our brain. There is no empty lot within our brain. There's no empty slot into which we could put more brain activity. Your entire brain is available to you at any given moment. And it is true that only a certain, there's never 100% of the brain that's active at any one moment. And if there were, that would be the biggest seizure in the history of seizures. Even seizures don't use, when somebody's experiencing seizures, irregular elevations of neuronal activity. Even folks who are experiencing grand mal seizure, like the worst possible seizure, are not exhibiting 100% of brain activity. Not only that, but whatever pattern of brain activity you're exhibiting is a byproduct of what your brain has learned to do in any given situation. And not only that, but just elevating brain activity would not correlate with improved performance in essentially any condition, right? Let's say you're taking a math test. If you were to just have more brain activity, that would not improve your score. If, let's say, you are trying to, be the best soccer player in the world, having more brain activity is not going to make you better at soccer. Was that the other myth in the book? No, I don't think it was. In fact, it would probably make you worse at all of those things. If you're taking a math test and, I just turned up the dial, cranked up your brain activity to 11, then you would probably be extraordinarily distracted because you'd probably be hallucinating, you'd probably be convulsing. And the reality is, you'd probably experience improved performance if you actually reduced brain activity, right? Rather than just elevated it non-selectively. You just want to focus in on just the specific part of the brain that you need to activate to accomplish the task and nothing else. Where is the brain located in the body? It is within the skull. Do you invest in Bitcoin? I have some Bitcoin that I've had since like 1 billion years ago, but it's not very much. Are vaccines safe for infants? Yeah. Yep. There have been now multiple studies that have, very large epidemiological studies that track specifically the MMR vaccine, because that is the one that the anti-vaccination community has honed in on, that has demonstrated it is safe. And not only is it safe, it is beneficial, right? We are fortunate to live in an era where we do not lose our children to polio or, measles. Well, you said infants. I'm just talking about children, right? You don't necessarily get your measles vaccine when you're an infant. You don't get your measles vaccine when you're an infant. I think you have to get that at 1 year old, but 1 year old, I should say. The anti-vaccination movement has given rise to a resurgence in certain diseases that were all but eradicated. We're seeing instances of polio again, right? I mean, when was the last time you worried about your child getting polio? I wouldn't worry too much. Now, here is where I begin to sympathize with the anti-vax community. Not in any of their claims. They're wrong about everything. Well, I mean, I don't know all of the arguments that come from the anti-vaccination community, but of the ones that I've seen, I've never seen one that proved to be true. Here's where I sympathize with what they experience. First of all, their concern over a potential cause for autism. They're wrong about vaccines causing autism. But here's where I sympathize with what they're experiencing. We do not know what causes autism. We have a lot of theories of what's likely causing autism, but almost all of those theories have very little to do with what you as a parent can change. The one that has been fairly consistently associated with autism and childhood environmental exposure is pollution. Exposure to pollutants that are PM 2.5 or lower, which means particulate matter that's 2.5 microns in size or lower, that has been consistently correlated with increased likelihoods of autism. And so you can mitigate that, either just reduce the amount of pollution to which your child is exposed, or do what I did or what we did. We got a bunch of air filters that can filter out 2.5 and smaller. But that doesn't necessarily mean that your child's definitely going to get autism if they live in a polluted area. It's just an elevated likelihood. But all this to say, I cannot tell somebody why their child developed autism. There is a community of people who feel like they can tell a parent. And not that autism is a curse or anything, but I think oftentimes parents want an explanation for why their child is unique. And when you have somebody telling them very confidently that they know the answer and they know the solution, that is seductive. And it's manipulative, and it's seductive. And not only that, but I have had my daughter vaccinated, and it is wild. I mean, it is very unique. It's a unique experience to watch, and it's an alarming experience to watch your child, your little baby, get injections. Of course, the baby doesn't like the injections. I don't like injections either, but, she's freaked out, right? And the last thing you want to see is your baby have to have a Band-Aid for anything. And so it's alarming. And when somebody's telling you that not only is what you're feeling justifiable, which as a parent, you just snap into defense mode. I go into gorilla mode or primate mode, and I'm just like, get away, But then my more Homo sapien impulses are inhibited, or my Homo sapien brain inhibits those more primitive impulses, and I'm like, this will enable her to live longer. So not only are you freaked out in that moment, but then somebody's telling you that whole thing was why you developed autism, and that's very, it's enticing to have an explanation for something for which there is no other explanation from people that are more scrupulous, that are waiting until we have an answer. That was a long tirade, wasn't it? Have you talked about anxiety at all? I haven't today, but I'm happy to. It's what my dissertation was devoted to. Anxiety is interesting. This is making me depressed. Why can't a scientist tell me about science? Well, Lil Cape, why don't you bring up some science? We were talking about science, however. We were talking about studies of whether or not there is actually any clinical evidence to suggest that vaccines cause autism. So thought I'll have quite the collegiate vocabulary by the time she's 5. All right. So yeah, we could talk about anxiety. It's a broad topic, but anxiety is an extremely adaptive property of human consciousness. It enables us to adapt to past experience, and it is distinct from fear in that you experience fear in the moment, but then because we have a relationship between the hippocampus, the amygdala structures, the extended amygdala, we are capable of remembering that fearful experience and learning from it and avoiding it in the future. All right, somebody from YouTube, La Lulus. Would you share some knowledge on the myelin sheath degradation delamination? Please, if some time permits. Yeah, sure. So I think what La Luz is describing, demyelinating diseases include the more well-known multiple sclerosis as well as Guillain-Barré. Multiple sclerosis is a disease where essentially the immune system is attacking the myelin sheath. The myelin sheath is composed, what it is, it's sort of like the insulation along the cables that connect brain cells. Okay, so not every organism has myelin. Some organisms did not evolve to have myelin, and so as a result, their solution for getting signals from one neuron to another neuron far away in space was to just have gigantic axons, right? So gigantic cables that enabled enough biochemistry to occur so that the signal wouldn't deteriorate by the time it got to another neuron. What we evolved to have, which was a very important evolutionary milestone, was myelin. And what myelin does is, if you look at neuron A over here and neuron B over here, for this neuron firing an impulse, for its ability, for that signal to reach the other neuron, it needs to travel quite a distance, right? And at the greater the distance, the longer, or the more and more the strength of that signal deteriorates over time, okay? And so what myelin does is it essentially cuts down that distance a little bit. It's myelin, M-Y-L, oh my God, M-Y-E-L-I-N, myelin. I'm not a spelling scientist, not a spelling surgeon. So it cuts down the distance functionally. M-Y-E-L-I-N. Yeah, I think I said that right. Anyways, and the way it does that is that rather than just having a neuron, a cable that connects them, an axon, and a neuron, what it does is it has just little points along the way that the signal needs to reach. And what's important about the relationship between myelin, signal propagation, and so on is that every time that signal emerges from the neuron, bounces to those points, which are called nodes of Ranvier, the signal is regenerated, right? And so it's as though it's sort of like a game of telephone, except it's much more perfect, where, let's say I'm trying to get a message to somebody outside of my apartment down the hall, and I have people along the way, and I can, say the word hippopotamus, and then the person at the end of my room says hippopotamus to the other person at the end of my door who says hippopotamus to the guy down the hall, and so on. That's how the signal propagates. And it's a system called saltatory conduction, based off of the term saltar, which is to dance. So these signals are dancing along myelin. Okay, so as you might be able to infer, the absence of myelin results in, it's as though I'm trying to get that message to that guy outside of my apartment, but there's nobody in here for me to say the word hippopotamus to, so he can't hear me. So, okay, so, and it arises due to the immune system attacking those cells that form the wrapping around which those signals have to bounce. There are different forms of multiple sclerosis, relapsing remitting, progressive, and it basically all revolves around just how rapidly symptoms are becoming worse, right, are becoming more severe. And in some cases, multiple sclerosis can essentially just result in sort of moments in one's life where somebody has an attack, what they call an attack, where there's just insufficient communication between the central nervous system and other parts of the nervous system. And so there are a bunch of different treatment avenues that are being explored. We can talk about some of them. One is to interfere with the immune system to prevent it from attacking those myelin cells. But then there's other approaches using more regenerative medicine, like stem cells, to recuperate for the loss of those myelin cells. So yeah, okay. Is it normal to have white matter on the brain? So white matter is myelin. So, oftentimes you can divide the brain up in many different ways. One is gray matter versus white matter. Gray matter are the neuronal cell bodies. When we say neuron, that's usually what we're referring to. White matter are again, it's composed of myelin. It is the connections between neuronal cell bodies. So yeah, it's very normal. Now, if you're referring to when you go to get an MRI or something and there's a lesion, oftentimes denoted by a bright white spot, that's different. That is not white matter. That is a lesion, and that's not normal. No. How to increase testosterone? There's a couple different ways, Dodd-Pan. One is to make sure, probably the most likely case is if you feel like you are, if you feel like you have insufficient testosterone for whatever reason. And by the way, if you're young, if you're like less than 29 years old, and there's no other obvious pathological state, like you don't have a prolactin secreting tumor or something like that, or you haven't had your testicles removed, you probably don't have insufficient testosterone. But if you're a little bit older, one easy thing to do is to make sure you're getting enough sleep. Testosterone levels are never higher in a 24-hour cycle than when you are sleeping. That is part of the reason for why guys can wake up with a morning surprise. It's because your testosterone levels are so high. Okay, so let's say you're getting 6 to 8 hours of sleep a night. That's not the problem. Another thing you can do is make sure that you have a competent diet. So testosterone is synthesized from cholesterol. A lot of folks don't know that. Cholesterol is the mother structure for both testosterone and estrogen, by the way. It is cholesterol. It has a sterile nucleus. Testosterone is a steroid. And so that doesn't mean that if you eat a bunch of cholesterol that you're going to get more testosterone. However, your body does synthesize. In fact, if you eat cholesterol, you're quite likely to not really influence your cholesterol levels all that much, contrary to popular belief. However, if you eat a bunch of fat, so cholesterol is synthesized in your cells, and levels of cholesterol are just basically genetically determined. You can influence it a little bit with lifestyle factors like exercise and diet, but it's really genetically determined. But you need enough fat to synthesize cholesterol, and so you have to make sure you're getting enough healthy fats in your diet. And then the synthesis of testosterone relies. It's just like any other enzymatic process. You need enough vitamins and nutrients to make it happen. I can't recall specifically which cofactors are involved, but you need a competent diet. Okay. Last thing, one of the easiest ways to elevate testosterone release is to engage in resistance training, weightlifting. Not only does it increase the size of your muscles, or at least your strength, depending upon which kind of weightlifting you're doing, but engaging in resistance training specifically, not like cardiovascular exercise, but weightlifting, elevates testosterone release. So do those 3 things and you should have healthy testosterone levels. Those 2 things. All right. Yes, we can't all be machos. In Area 51, what could cause a stroke at a young age? Stroke is super frustrating, like as a clinical challenge. Genetics. I mean, cardiovascular abnormalities. If you have high blood pressure, low blood pressure, just cardiovascular, deviation from what would be a healthy range can be an indicator that one is at risk for stroke. But if somebody has a stroke at a young age, generally speaking, there's something genetic going on there. I'm not lazy. I'm just producing testosterone. What happens if the government made me gay? I would love to hear that story. If the government made you gay, Are you talking about juice boxes? Because if you are, I don't think you're right about that. All right. It's not a tumor. It's not a tumor. Are others sheath faster or slower than others sheath? What the fuck? So, that was close. No. So I think what our friend here is referring to is, we were talking about myelin and how it enables signals to get from distant neurons to one another, and it does speed up conduction. So are there differences between different people and how fast signals propagate? No. Essentially, all the mechanisms that govern the speed of propagation of a signal, the generation of an impulse or an action potential in general, those are all consistent among not only like all humans, but all animals with nervous systems. And so, certainly mammals, let's say. So no, it's not like somebody who's smarter, let's say, or somebody who you feel like is smarter than you. It's not like their brain is working faster at a, nitty-gritty biological level. It's rather that they have amassed more information in that topic than you have for whatever reason. Okay, dynamic comics. What does it mean when the top of your skull, the crown, is hot or warm to the touch? Had it for quite... I guess I didn't see the end of your topic. I'm not sure. But it's worth noting that the discerning body temperature, using your own body, is actually a very inaccurate way to discern body temperature. That's why, physicians don't usually recommend testing whether or not a child has a fever using your own hand, just because it totally depends upon your own body temperature. And the temperature of your extremities is not necessarily consistent with that of your core. And so, I would suggest that you scrutinize that a little bit. Maybe get one of those temperature guns, that can sense your temperature using light or whatever. But that would be that's what I would suspect. Ian, you still holding this down? Oh yeah, at least for a little while longer. Hi, what's up, Margaza? All right. Why isn't mental health taken seriously? Well, Shady One, it is frustrating, but I think it is increasingly being taken more and more seriously. But I think part of it is that it is completely intangible. It is, nobody underestimates a broken leg or compound fracture because you can see it. There's a physical manifestation of this malady. And then even when it comes to diabetes, where you can't see the problem necessarily, you can't see the insulin insensitivity or insufficient production of insulin, but you can see the ramifications, right? People can pass out, people can die, people can have seizures, and so on, right? Or you can lose limbs potentially, and we know that's due to diabetes. When it comes to depression or addiction or any of these psychiatric conditions, the manifestations of them are behavioral, mostly. I mean, of course, for the individual, the manifestations are internal and mood associated and internal suffering and that kind of stuff. But I mean, for people who are observing, it's behavioral. You're just seeing them engage in behaviors that for you would be entirely irrational. Like, why don't you want to get out of bed? There's so much to do. It's beautiful outside. Let's go outside. Let's go exercise. Right? For you, it seems completely irrational, but that's because you are not experiencing their internal brain state. And so I think that is the primary obstacle that separates people from being able to empathize or sympathize with folks suffering from mental illnesses. So I think that's why. I can't tell you for sure. You can see epilepsy, but you can't see a seizure. Well, I know what you're saying. You can see a seizure in the way that you can see epilepsy in the respect that you're talking about. Meaning, if somebody's convulsing, you can see that they're having a seizure. And you can see if it happens regularly that they have epilepsy. But there are also some seizures where there's no obvious manifestation. These are non-convulsant epilepsies. But in some cases, you can still see that there's a seizure. It's just not as obvious. Like, for example, absence seizures, where people will just sort of drop out of being being responsive to their environment. Sometimes they'll engage in some slightly repetitive behaviors, but they're not like convulsing. There's also drop seizures where people just lose the ability to maintain muscle tone, and so they just fall. But then there are also a whole set of seizures that one can experience where there's no obvious outward manifestation, even subtler than any of the ones that we just talked about. And so you can see those. You can't see those physical manifestations, but they're still happening. So I mean, I agree with you ultimately. Can cannabis quell mental illnesses like anxiety and depression? Cregan, yeah, right. So the short answer is it can, but only in certain people. And oftentimes, for some people with mental illnesses, it can exacerbate them, particularly anxiety-associated conditions. Cannabis can help reduce anxiety in some people. Anecdotally, there's not a lot of clinical evidence that it's effective for that. And that could just be that some folks feel elevated anxiety, but they're not formally diagnosed. And so, that could be part of it. But there's also the propensity for some people to experience anxiety attacks and panic attacks from cannabis. So it's not like cannabis is a very complicated drug pharmacologically. It's more complicated than most drugs people take recreationally. And there are genetic differences in how people respond to the drug. And so it's not a panacea. No drug is. But for some people, in some cases, yeah, it can be helpful. Are bigger brains better? The short answer, well, generally speaking, yes. Having more neurons is better if you want to have a conscious organism. But that is not the end-all, be-all. There are animals that have more neurons than humans have, but they're not as intelligent or versatile as humans. But there is a reason that a shrimp is not ever going to be as conscious or intelligent as a human, right? You need a certain level of complexity to sustain intelligence, right? To sustain consciousness. But so, are bigger brains better? Yes, but that is the answer. Where did you earn your PhD? Temple or Villanova? University of Pennsylvania. And I still have some revisions on my dissertation, but I'm basically done at the University of Pennsylvania in Philadelphia. All right. What do you recommend to improve intelligence besides learning foreign languages? Oh, man. Well, I mean, it's tough because, it depends on what you mean by intelligence, yada, yada, right? For me, I always use, what was it? You said foreign language. Yeah, I mean, that is just one example of just confronting your brain with challenges that it has to generate new solutions, for which it has to generate new solutions, right? So learning a musical instrument, right? If you don't know how to play or even if you know how to play a musical instrument, learn a new one. Learn how to dance, play a new sport, learn a programming language, if you can do that. Read books that are sort of outside of your wheelhouse. Try writing a story. Just try engaging in cognitive tasks that are foreign to you, that aren't simple and easy for you to accomplish. Like, for example, I just got a thing. It's an art project, but it involves a lot of soldering and sort of engineering. And so I had to do a little bit of soldering for my PhD, but not really, not that much. And so I'm going to learn how to do all that stuff. Just develop a new skill. And not only, I mean, it's beneficial for your intelligence because you're developing new strategies to solve new problems, but it enriches your life, right? I can beat you at words with friends too. Maybe it's possible, unless it's neuroscience words with friends, in which case I bet I could give you a run for your money. What did you solder? So I haven't done it yet, but it's sort of like an art project. You'll see it. I think I'll put it back here somewhere when I'm done. Force yourself to read articles that you have no interest in. Yeah, I mean, well, you can be interested in it, right? But it's just, like, for example, in philosophy, if you're interested in philosophy, I find it interesting to read the philosophies of those with whom I completely disagree, right? So, at least within neuroscience, reading about compatibilism or dualism, or those that argue that there are certain problems in neuroscience that we'll never be able to solve, or those that argue that we have free will. Like, I read those things. I don't find them convincing at all, but I think it is a beneficial exercise, I would suggest to you, to go through their line of reasoning, because it's not your own and it's not intuitive. You don't know where they're going to go necessarily. Or when it comes to politics, like reading the explanations of people, of their positions, of honest actors, not, just circus barkers, but even if you completely disagree with them, taking their perspective a little bit, I think, is a beneficial exercise. Do mathematics backwards. I'm having trouble doing mathematics forwards, so that'll have to be down the line. Does this mean many of our government are shrimp? I don't know what you mean by that. Is Prestique a good medication for anxiety? I'm not sure. I'm forgetting what the name, what Prestique actually is. Like what the non-trade name of Prestique is. But if somebody's there is this article in The Atlantic that sort of indicted a lot of the biomedical system, but I would be surprised if a physician would prescribe a medication for anxiety-associated conditions that had no basis in efficacy. All right. What effects do beta blockers and AA have on the brain and heart with AFib? AA? I'm not sure what you mean by AA. Beta blockers block the beta adrenergic receptor, beta adrenergic receptor. And so the reason oftentimes, well, it depends on which beta blockers you're talking about. If you're talking about beta blockers that are used for cardiovascular pathologies, that's slightly different. But if you're talking about like propranolol, which is used to treat, used to mitigate sort of situational dependent anxiety, it can have a cardiovascular effect, but it's not. What it does is it essentially blocks the activation of the cardiovascular system by stress responses. But in terms of AFib, I'm not sure what the interaction there would be. I would imagine it's not recommended, but I'm not sure. I'm not a physician. All right. Oh, thank you very much for the heart, Mark. I appreciate it. Super hard. I mean, all right. What country leads in cutting-edge brain science? And did you study neuropharmacology? So I am a neuropharmacologist at heart that has then transitioned into a circuits guy. That is really where I came up, though, was in neuropharmacology. So what country leads in neuroscience? Well, I mean, so the United States is still the sort of the predominant engine of biomedical research. But it by no means is it like just the out and out dominant entity. There is fabulous research and plenty of it that comes from Brazil, all throughout Europe, and the Scandinavian countries. The UK, of course, does a lot of great research. China is doing a lot of research, but their whole model is very different in China. Japan, the Riken Institute in particular, great research. There's some interesting research from Australia, like Queensland University, I see all the time. Where else? India, there's some interesting research that I've seen. There's interesting research that I've seen in Turkey, has a lot of neuroscience research. I don't know if I said Brazil. Oh, Mexico. There's a lot of interesting research from Mexico. Canada. It's all over the place. But in the United States, there's so many research institutions, and we fund the National Institutes of Health not as generously as we used to. We used to fund it much more generously, but it is generous relative to a lot of other countries are capable of doing. And I should say, funding for the NIH has definitely declined, just because the number of funds has not really changed all that much over the years, but the inflation, purchasing power of the dollar has declined. So it's worth keeping in mind. What sources do you recommend to keep up with brain research? I actually compiled a list, but it's on a different computer. Well, so one of the best is Eureka Alert. Hey, from Turkey. I was just talking about Turkey. Eureka Alert is kind of like a science media outlet of science, of AAAS. So it's Eureka Alert. Eureka Alert. And it's Eureka, I think, exclamation point alert or something like that. Anyways, yeah, they're pretty short articles, but they're pretty accurate to the actual research, and oftentimes they have quotes from the actual researchers. Neuroscience News does a pretty good job most of the time. They do tend to have clickbaity titles, but it's not like that's a crime that's unique to them. And oftentimes the actual articles are pretty good, and like sort of comparable to Eureka Alert. So those two are good. Now, of course, the biggest science publications like Nature, Neuron, Science, they have their own sort of like news postings, summaries of the articles that are worth checking out if you want to stay up to date. So, Nature, Neuron, not so much, and Science. But, Eureka Alert, I think, is one of the better ones. All right. As in Eureka Alert. Yeah, exactly. What do you do to refuel your brain after a long day? Well, recently I've been reading this book, Play with the Daughter, because she's like endlessly fascinating and adorable. I have been back in the gym. I had sort of neglected the gym, particularly while writing my dissertation and having a newborn. There was no gym. It was like not possible. Yeah, those are the things. I do both weightlifting and cardio exercise, high intensity interval training. All right, are Pop-Tarts a good fuel for the brain? In a pinch, but not really. Not the healthiest source of calories. All right. You said Brazil, but India, of all places, super. Yeah, great research. My fear is a country will discover something about brain science and weaponize it. We are already at a state in biomedical science where it would be like shockingly simple to manufacture a very dangerous biological agent. In fact, I'm pretty shocked that has not happened. Like, I'm like shocked because there are definitely entities in the world that would be interested in wreaking havoc and committing atrocities, and like, I'm just so surprised because it's so easy to make them. But I guess, if you go through enough of the training to be able to make a virus or make a bacterium, or, engineer a bacterium, then maybe you've invested enough in society that you're not likely to join those groups, I guess. I'm not sure, but so we're already there at least. Now, what you're talking about, I suspect, is more technological. And yeah, I mean, just like, online social media has been weaponized socially to accomplish certain, nefarious goals. So will the integration of technology into the nervous system. But that's true for all technology, right? I mean, again, the automobile, upon its invention, was thought to be one of the most dangerous things ever, and so many people were going to die. And by the way, automobiles have been used as weapons recently, right? And so your point is well taken. Yeah, there will be threats to the integration of technology into the nervous system, but we know that. And so we can prepare for that. And, like for example, when it comes to like, these deep fakes, these AI generated, false videos of like people speaking things they've never said, or pornographies where, you can make it look like somebody has done a pornography that they've never done. There are also artificial intelligence systems that are capable of detecting whether or not there are deep fakes. And so, it's going to just be a new domain of warfare that, it's happened over and over and over again throughout history. Who's that behind you? You mean this? That's a butterfly. That's also a butterfly. It's a moth. This is a painting. And that's also a painting. That is that's a moth, a Luna moth. Those are some bugs. And that is the golden monkey king right there. So much is being unlocked with our genome lately. Your thoughts? Well, I don't know that things are being unlocked with our genome, but we are certainly living in an era where it is remarkably easier to alter the human genome forever. To alter germline, meaning like sperm and eggs, genetics, which would then result in permanent changes in the gene pool. So my thoughts are, one of the inventors, so a lot of this stems from the invention of CRISPR-Cas9, which is like we've been able to modify genomes for a very long time now, but CRISPR-Cas9, it's sort of like the scalpel compared to the sledgehammer. And so you can get very precise in your genome edits. And so Jennifer Doudna, who is one of the inventors of CRISPR-Cas9, has been extremely insightful on and has participated in conversations about, okay, we have this technology. We're still not at the stage in genetics research, functional genetics research, where we can say, okay, I want my child to have, whatever, green eyes, to be 6'5", and to not have any predispositions to addiction. Make my baby. We're not at that stage yet, but we will get there. And we know, at least there are reports that CRISPR-Cas9 has been used in China to alter twins. For an odd reason, that he was altering them to treat HIV that they might have received from their parents, which is just a weird reason to use CRISPR-Cas9. Anyways, and so it is doable. It is quite likely being done, and we've not heard of it. But we are still not at the stage where this is like, it's happening in your backyard, and in fact, people have tried. Like, there are videos of people injecting themselves with CRISPR-Cas9 cocktails, but they don't work, right? Because they don't know enough of the biology to recognize that there's an immune system reaction, or that the reagents are just not going to react where they've injected them or react with each other properly. And so it is still very complicated, and we're not quite at the precipice of this quite yet, but we will be. And again, once again, it's just going to be the kind of thing where we have to anticipate. Unfortunately, we live in a circumstance where folks like Jennifer Doudna take it upon herself to participate in the conversations of, okay, how do we adapt to the reality of this technology? How do I make a nuke? I'm not sure. Can taught empathy for a depressed person put you at risk of depression, Ian? Can taught empathy for a depressed person put you at risk of depression? I'm not quite sure what you mean by taught empathy. Can taught empathy for a depressed person put you at risk of depression? I guess, are you referring to like codependence? I guess I'm not 100% clear on where you're going with that. Like, maybe you mean if you're empathizing with somebody who is depressed, can that make you depressed? I would imagine, but I don't have any concrete, anything tangible to grip into to talk substantively about that topic. Okay. Does my left eye control the right side of my body? No, your left eye doesn't control any part of your body. But the left hemisphere does, generally speaking, control the right side of your body, and vice versa. The left side controls the right side of your body. And that is because the projection decussate, they cross. So there's that. But actually, the eyes are a little bit more complicated. So it's not like, your right eye is controlled by your left hemisphere of the visual cortex. Actually, your eye is divided in half. Both eyes are divided in half. And so if I remember correctly now, the right division of your left eye will go to the left side, the left hemisphere, I believe. And then the left... okay, I might be getting that anatomy screwed up because it's been a while since I taught intro neuroscience. But it's actually not as simple as one eye goes to one side, the other eye goes to the other side. It's half and half, which is remarkably complicated and odd. Another testament to how messy our nervous system is. I'm about 10 years older than you. With age comes wisdom, but I'm apprehensive about internet fakes. Well, I'm definitely apprehensive about internet. I'm not excited about them, but I'm also, I wouldn't make them, right, if I were asked to. But I think I just never see people bring up the availability of artificial intelligence systems that can detect deepfakes. Let's see. Are there parasites that can get into your eyes and nibble on your photoreceptors? Cool. Oh, there are parasites. That is cool. It's also very freaky. How to program your subconscious the fastest way. And then, can scientists create consciousness? From Ethan Hawke. Okay. How do you program your subconscious in the fastest way? I don't know that anybody's quantified just how quickly one can meaningfully engage with the subconscious. It is, by definition, not a property of the nervous system that is available to conscious interrogation. But if somebody were to interact with you in a way that engages your most primitive impulses and urges, like, for example, how marketeers essentially try to appeal to, your sort of most primitive urges, that I suspect would be the way. And then, have scientists created a consciousness? They have not. They have created very restricted versions of artificial intelligence, but have yet to create something that is even close to conscious, or certainly even a general artificial intelligence. But anyways, the girls are back from their walk, so I have to call it a day. Thank you so much for hanging out, everybody. I have a podcast. It's called Wired to be Weird on iTunes and Stitcher and Spotify. Let me know what you think. Drop me a 5-star rating if you are so inclined. I have a Patreon. It's patreon.com/anthropoid. I'm working on my next podcast episode, not as we speak, but after we speak. It's either going to be, I'm working on 2 topics that I'll talk about both. One is the effect of fasting on the brain. The other is the experience of getting a PhD, the actual defense. Like, what happens when you're in a room with wizards trying to throw any spell that they can at you to reveal your weaknesses. So I'm working on those. Patreon.com/anthropoid. If you're in a position to throw me any support, I would be deeply appreciative, and I would love to set up a time to chat with you more personally if you are interested. Otherwise, have a great beginning of your week, and at a minimum, I will talk to you at some point this week. And until then, have a great week. See you guys. And thanks, everybody on YouTube who hung out. I know it's not quite as crowded in here, but that gives us a little bit more space to breathe, doesn't it? All right. Yeah. Thanks for hanging out, everybody. I'll try to be a little bit more organized next time. But until then, I'll be working on that organization. All right. See you guys.